Working with Compound Figures, Part 1, Perimeter.
So today we're going to talk about calculating the perimeter of a compound object. By now you should be used to getting the perimeter of simple objects like triangles and circles and rectangles and squares. Now we're going to look at a figure like this one, which is a swimming pool of an odd shape. But notice it contains a half a circle, a rectangle, and you'll notice the length of that rectangle is 6 minus 3 meters, which is 3 meters, and it also has a triangle. So, what I can usually do is I calculate the perimeter of the rectangle, and then basically shape by shape. So I get the perimeter of the rectangle, the perimeter of the semicircle, and then the perimeter of the triangle. The one thing you have to keep in mind is that you don't want to get this side and this side because it is inside the figure and it doesn't count as part of the perimeter. You want all of this. So, let's start by getting the pieces that are involved in the rectangle. Remember, we don't use this piece. So let's add up the 3 meters plus 6 meters, plus let's add the 3 meters again. Okay? And that should give us a total of 12 meters. Then the second part is the semicircle. This is what it would look like if it were a full circle, but we only need half of the circle. Notice the diameter is also 3 meters, and therefore you can get, if it were an entire circle, you could get the circumference or perimeter of a circle by taking pi times the diameter, 3 meters. But I'll put p of 1/2 circle down here. It's going to be pi times the 3 meters. But remember, we're going to divide the whole thing by 2 because we only want the perimeter of half the circle. Finally, we want to look at the perimeter of 2 of the 3 sides of the triangle. Now, you will notice that this side does not have length, but that's okay because you can use the Pythagorean theorem to find that. And the Pythagorean theorem says if you have 2 sides, A and B, and you have a right angle like this one, the side opposite is the hypotenuse, we'll call it side C, then the Pythagorean theorem says A squared plus B squared is C squared. And you notice that each of these sides here, A and B, are 3 meters. So you get 3 squared plus 3 squared is equal to C squared. Well, that's equal to 9 plus 9. Or if you turn it around, C squared is 18. And C is the square root of 18. Replacing the values here and here for the half circle and triangle with the rounded off decimal value gives us that the perimeter of half of the circle, or the circumference of half of the circle, is 4.71 meters, and the perimeter of that portion of the triangle that is on the exterior of the compound figure gives us 4.24 plus 3, or 7.24 meters. So now, to get the perimeter of the entire figure, we just add each of these 3 values. So P, meaning the perimeter of this entire compound figure, is going to be 12 meters plus 4.71 meters plus 7.24 meters. And when we add up these 3 values, we get a total of 23.95 meters as the perimeter of this swimming pool.